back to the channel, guys. Thank you so much for joining us. Well, if you're watching this video, it simply means that you're studying for your CSEC examinations, integrated science, and this is paper 2, May-June 2017. So let's see what this paper has in store for us. Now remember, this paper consists of 6 questions in 2 sections, and you must answer all questions. So let's see the first question. Section A. It says, answer all questions. Sandra lives on the island of Montserrat. Her father buys an electronic weather station which he installs and connects to the computer in the air-conditioned computer room. There is a small sensor which has been hung on a nail in the backyard shed. It collects weather data, temperature, pressure, and humidity, and sends the data to the main unit which attempts to predict the weather. What kind of weather would most likely be predicted when the sky is full of dark gray nimbus clouds? And the answer is rainy or stormy weather. And even if you don't know what a nimbus cloud is, guys, from you see the words dark and gray, whenever clouds are dark or gray in color, it simply means that there's a chance of rainy weather. The next part of the question asks, what kind of weather is most likely expected when the atmospheric pressure is rising? And that would be sunny weather with clear skies. And if you listen to the weather, or say for instance the weather channel, whenever you hear the meteorologist saying that they're going to have a high pressure ridge, it simply means that there is going to be hot, sunny, clear weather. But once they talk about a low pressure ridge, it's going to be some kind of stormy weather. Alright, so bear that in mind, guys. The next part of the question asks, the weather station indicates the forecast of rain and the news announces that the hurricane watch has been upgraded to a hurricane warning. State 3 appropriate activities that Sandra's family should undertake to prepare for the hurricane. So, for one, Sandra's family should store a week's worth of clean drinking water in airtight containers, guys. 2, she can purchase non-perishable foods such as dry goods as well as canned products. 3, ensure that there are battery-operated devices such as your flashlights, your radios, your small appliances that have batteries. Just make sure that you have good batteries for those appliances. And 4, secure windows and doors by applying battens, or what we call in the Caribbean batten up, or just use boards and bar the windows and doors. So those are some things that her family could do, and I guess everybody is familiar with preparations for a hurricane. Now this next part of the question asks, explain how a hurricane develops. Now hurricanes are formed when damp air rises from the surface of warm tropical seas. The sun heats the air, and then as that warm air rises, there's a powerful updraft because such a large amount of water is evaporating at once. This then cools down and turns into a lot of clouds, which would eventually become rain. This updraft, or this constant rise of warm air, is kept fueled as more hot and moist air rises. With the constant rainfall and updraft of winds, tropical storms gradually develop until the hurricane is formed. So that is how a hurricane develops. Alright? And then you know that the center of it would be the eye, and then it would have wind speeds of a certain wind speeds of a certain amount. Then it would be categorized as a hurricane, moving from a tropical depression to a tropical storm, then to a hurricane. And that would be for 3 marks. So you can do a little bit more reading on how a hurricane develops. Next part of the question. So section B. In 1995, the Soufriere Hills volcano erupted, and I may be pronouncing that incorrectly. Identify 2 hazardous materials produced by the volcano, and for each material, suggest 1 effect on Sandra's community. Write your answer in the following table. So it's asking for a hazardous material, and then it's also asking you for 1 effect of that hazardous material on the community. Now think about the parts of the community. It could affect the water, the plants, the animals, the people, the infrastructure, anything that makes up the community. So think about parts of a hurricane, which not a hurricane, sorry, and volcano that is harmful. All right. So one of those materials is the sulfuric ash or the volcanic dust. So you know, once a volcano is erupting, it's going to produce ash and dust, and the effect of that ash or dust is that it can create eye and upper airway irritation for the people in the community, and the ashfall can also cause minor to major damage on vehicles and buildings. It can contaminate your water supplies. It can even damage or kill vegetation if you have a lot of it. It can also block out the sunlight and prevent plants from photosynthesizing. So if you remember that volcanic eruption back in the St. Vincent and the Grenadines, right? A few years back, I think it was in 2020, that large block out from the sun lasted for a couple of days. Well, so that could affect the plants too. The magma or lava, which is fast moving molten rock that you usually see coming out of the top of the volcano and running down the sides. It can kill people and destroy the environment by burning plants and animals, and also starting fires, and this can even affect the soil. So any of those 2 hazardous materials and what they actually do to the community would give you 4 marks. All right. Next part of the question says, Kik-M Jenny is a live submarine located near northern Grenada. Suggest 1 effect of an eruption of Kik-M Jenny on the ecology of the coast of Grenada. So when they talk about ecology, it's talking about the plant and animal relationship, that environment. They are like the ecosystem. And for persons watching from Grenada, you would probably be familiar with Kik-M Jenny. Now, 1 effect of this submarine volcano, and if it says submarine volcano, guys, it's talking about a volcano that is actually under a body of water, so like it's under the sea. So this can raise the temperature of the water, right, which can lead to bleaching of coral reefs. For those who do a little bit of geography or even social studies too, sometimes you'll hear them talk about the bleaching of the coral reefs and why we should protect coral reefs. This is one of the reasons. If we have high temperatures of waters, coral reefs are bleached, and just as the name suggests, they actually lose their pretty colors and turn white. Another effect that can happen is that the magma coming into contact with the water. So as the volcano is erupting and that magma is coming out, the water will cool it in an instant, and then this can form some really large rock formations that can block the sun from plants that live under the water, so they also suffer because they're not gonna get sunlight to photosynthesize, and some sea creatures may die from the heat as well, and their habitats may also be destroyed. So there are a lot of things you could pick on to answer this question, and any one of those would have given you 2 marks. So let's see the next part of the question. Sandra has accessed the data in Table 1 from the weather station. Table 1, atmospheric temperature from Saturday morning to mid-morning Sunday. So it gives us the time and it gives us the atmospheric temperature in degrees Celsius. And this is our graph question, guys. So we have time, 6 a.m., 10 a.m., 2 p.m., 6 p.m., 10 p.m., then 2 a.m., 6 a.m., 10 a.m., and they all of those times have a temperature recorded for the atmospheric temperature for that time of the day, and it's leading from Saturday morning to mid-morning Sunday. So let's look at the questions that follow. So it says on the grid provided on page 7, plot the data presented in table 1. 2, it says draw the best curved line to show the trend. 3, it says label the axes on the graph. And 4, state an appropriate title for the graph. Alright, so we already know which pieces of information are going to go on our graph. So we can state an appropriate title for the graph already just by looking at the data. So I have here a graph showing the atmospheric temperature plotted against time from Saturday morning to Sunday morning. Alright, so we have time going on our x-axis and atmospheric temperature going on our y-axis. So that's a title. You can rephrase your title in any way, but it should just state what exactly you have going on in the table, the pieces of data you have being represented on the graph. So that's your title. Part 2 says that we should draw the best curved line to show the trend and label the axes for part 3, and both of those combined would give us 4 marks. So let's go down to the blank graph and see what we would do there. Alright, I know the graph looks a bit confusing, but it need not be because it's simple. So let's answer this first part. It says we should label the axes on the graph. Now, if we just use the indicated information here, because they fill it in for you already, and that's what we love about our graphs in integrated science. They have already done some of the work for you. So where you see 6 a.m., 10 a.m. the times, you would just label it as time, and that would be for 1 mark. And where you'd see the other figures, you know it's atmospheric temperature, you put that title there to label your axes, and you would get 2 marks for that, guys. That's 2 free marks. Easy giveaway marks. So then we're going to look at our table to just make sure we have the data, and then we're going to start plotting our points. And if you don't know how to plot points on a graph, you need to go and watch some of the other videos from Past Papers 101 with Miss Edwards, where we go through some detailed graphs showing you exactly how to plot your points and how to make those best fit lines, or in this case we're going to make a best curved line. Alright, so just go back to one of those videos, look for where you see I'm speaking about the graph, and you will get to understand what to do. So let's just look at 2 other points. It says the time 6 a.m. and the atmospheric temperature is at 22.6 degrees Celsius. So we're going to try to plot that point on the graph. So we're working with 6 a.m. and 22.6 degrees Celsius. So let's find 6 a.m. It's right here on this main line going up, and our atmospheric temperature was 22 point, let me see, 22 point, what was it again, 22.6, right? So we have 22.246. So it should be up here. I don't know why I have mine down here. I'm just gonna erase, because we all make mistakes. And then this graph is, you know, it's not on paper. So 22.246. Here is where the point should be. Alright, right here. So let me circle it. Remember, guys, when you have a better graph paper, a literal one in front of you, it's much easier. But this is showing you how you would set it up. So we have a 6 a.m. here on the line, and as we go up, we try to find that 22.6, and this is where they meet, both the time and the atmospheric temperature. So we put a point and we circle. And that is what we did for the rest of the points. Wherever you see me have a little point circled, that is one of the pieces of information that was in the table. So I moved up, and you see the points are basically all over the place, but in general, let me zoom out a bit. You see that we have a little, almost looking like a little roller coaster thing going on. We have an up the hill motion, down the hill motion, and then back up the hill again. So when they asked us in the second part of the question to draw the best curved line, this is what they were talking about, because it would not give you a best fit line per se. So it also asks us to show the trend. Now the trend is basically a pattern. So looking at the graph, if we followed the time during the day, right? Remember, we're starting from Saturday morning to Sunday mid-morning. It starts at 6 a.m., 10 a.m., then 2, then 6 p.m., 10 p.m., going right back to 10 a.m. the next day. We see that there is an increase in atmospheric temperature, and then we get a peak, and then we go right back down as the day progresses, and then at a point in the day and the next day we realize that it goes back up again. So we have this trend. So that's why my best curved line looks this way, because it must show the trend. So it's basically you just using your free hand, because there is not a ruler to draw this. You're just gonna use your free hand and draw a line as much as possible to get through those main points to show the trend. So my main points would be here where I have the highest point, and then down here where I have the lowest, and then back up the hill again. So I must show that there was a rise, then a fall, then a rise again. So that's why my graph looks like that. So if they're asked for a curve, try and see where you can see where it does make a curve. And if I had this on regular paper, guys, it wouldn't be so straight. So you plot your point, and then you try to connect all or as many points as possible on the curve or based on the pattern you see. And that is for 2 marks. Just drawing that curvy line will give you 2 marks. Then it asks us, let me just zoom up again. From the graph, determine the maximum temperature over the entire time by drawing dotted lines to read its value. So the hint here for this answer is we're looking for maximum temperature. So all you have to do is look on your graph and see which of the temperatures given was actually the maximum or the highest. And in this case, it was right here at 34.246, 34.6. Now, because it says we have to show using a dotted line, you would draw a dotted line from the time going up where it actually occurred, or where this temperature occurred at 2 p.m. and then where it touched the best curved line and bring it out. So they're just asking us to show using dotted lines, and that would be your point. And that's why I put the word or the phrase highest temperature here, to just show you that one. And then they asked us from the graph, determine the temperature at 4 a.m. by drawing dotted lines to read its value. So let's look at the graph to see what happens at 4 a.m. So remember, if over here starts at 6 a.m., the only place we would find 4 a.m. is on this side of the graph. I hope you guys are seeing my cursor. So we have right here 2 a.m., 4 a.m., 6 a.m. because you realize every 2 centimeters is 2 hours ahead. So this would be 4 a.m. So all you do is draw your dotted line going up, and wherever it touches your curve, that's why you do your curve first, that is going to be the temperature it would have at 4 a.m. And when we read it going across to where atmospheric temperature is, it is at 21.0 degrees Celsius, and that is why on the line here my answer is 21 degrees. So that would be your first question for 25 marks, guys. Remember to go and practice your graph skills. Moving on to question 2. It says state the name and function of one major blood vessel. And one major blood vessel would be the veins. You could have also said the artery. And the function or a function of the vein is that it transports deoxygenated blood from organs or body parts to the heart or towards the heart. That's for 2 marks. Next part of the question says, state one feature of the blood vessel named above. Now, if it says feature, they're asking you about a structural part of the thing. So if you chose the vein, you have to think about the structure of a vein. What does a vein have? How does its structure look? What's a feature of a vein? Now, Veins actually possess valves in order to prevent the backflow of blood. If you had chosen to say capillary, they are one cell thick for diffusion, and if you had chosen the artery, arteries have thick muscular elastic walls and a small lumen. So if you were to choose any one of these, whether the vein, capillary, or artery, you need to know something about their structure, and that would be for 1 mark. Alright guys, so refresh your minds of what goes on during circulation and the heart. Go back to that grade 10 topic. Part B of the question says, a student wants to determine the effect of exercise on pulse rate. She records the pulse rate of 5 athletes, then asks them to jog around the track for 2 minutes, and immediately records their pulse rates again. She allows them to rest for 5 minutes and records their pulse rate again. She obtains the results shown in Table 2. So let's have a look at Table 2. Table 2 says the effect of exercise on pulse rate. Athletes A, B, C, D, their pulse rate before, their pulse rate immediately after jogging, and then their pulse rate 5 minutes after jogging. So let's look at those athletes. Athlete A is 60 before. Immediately after jogging, it's 150, and then 5 minutes after jogging, it's at 75. So we see a decrease there. Athlete B started at 62 beats per minute, and then immediately after jogging, it was at 145, and then after jogging, after 5 minutes, it was at 74. Athlete C was at 65 beats per minute before jogging, 155 beats per minute after jogging, and then 80 beats per minute 5 minutes after they had stopped jogging. Athlete D, 58 before, 145 immediately after, 58 5 minutes after stopping, and then athlete E was at 61 before, 155 immediately after, and 85 after 5 minutes after they had stopped jogging. So let's look at the questions. The first question asks us to define the term pulse rate, and pulse rate is basically they're basically giving you a little hint when you see it in the table here that says BPM, beats per minute. That's what BPM stands for. So what beats per minute, guys? What in our body beats? It must be the heart. So the pulse rate is actually the number of times your heart beats per minute. So that's why when you take your pulse rate, you can tell if how many times your heart had beat. If you feel or count the amount of pulse at your wrist, you can take it there. No, that's for 2 marks. Simple question with a simple and super easy answer. Part 2 of the question says, name 2 variables that are held constant in the experiment. And if you've done your experiment, guys, you know variables, you can have them being manipulated, responding, or actually constant. So manipulated, controlled, or responding. So if it's constant, it means that it's not changing. So they're asking you what things are the same right throughout the experiment. So if we look back, we have to pay attention that all of these athletes were asked to do the same exercise. All of them were asked to jog around the track, and then the other constant thing was that they only did it for 2 minutes. So the time and the exercise that they were asked to do for that length of time was the same right across the board. So that's for 2 marks. The next part of the question asks us, from the data provided in Table 2, describe the effect of jogging on pulse rate. And they ask us, what is, the effect of jogging on pulse rate immediately after jogging. So let's look at the table again. Let's look at the trend. What usually happens immediately after jogging to the beats per minute? Just look at it before, but look at the ones after. What do you see happening there? 60 to 150, 62 to 145, 65 to 155. Basically, we see that there's an increase in heart rate or pulse rate immediately after jogging. So the effect that jogging has on the pulse rate is that the pulse rate is high due to the exercise, and there is an increased circulation of blood. So there's an increase in pulse rate. So exercise increases circulation and pulse rate, and that's for 1 mark. Let's look at the next part of the question. It says 5 minutes after jogging. So what's the effect of jogging on pulse rate after 5 minutes after jogging? And if we look back at the table, we realize that immediately after jogging versus the 5 minutes after they had stopped, it shows that there's a decrease in the pulse rate. So the effect that resting, right, would have on the pulse rate is that it actually goes down. There's a decrease in the pulse. So let's look at the next part of the question. It says, use the information from table 2 to determine the athlete who appears to be the most fit and the athlete who appears to be the least fit, and give a reason for your answer. Now, you already saw my answer, who is the most fit athlete. It's actually athlete D. So let's look at athlete D in the table and see why I said it was athlete D. Now, if you look at athlete D, his pulse rate before jogging was at 58 beats per minute, and immediately after jogging, it was at 145, a rapid increase. But then 5 minutes after jogging, it was at 58. Now, what do you see right across the board? It was 58 before jogging, and it is now also 58 after 5 minutes after they had stopped jogging. This is an indication that his pulse rate returned to normal within the 5-minute recovery period. And if you remember learning about pulse rate and even physical fitness, you would know the quicker the body goes back to its regular heart rate after exercise is an indication of fitness or physical fitness. So if you return to your normal pulse rate quicker, then you are fit. But if you take a longer time to return to your normal heart rate after exercise, it is an indication that you are not so fit. So that is the reason for me choosing athlete D as our most fit athlete. So a way to state that, it would be that athlete D, his pulse rate returned to normal or the resting rate within the 5-minute period, and his recovery time is shortest, making him the most fit. So it also asks us for the least fit. So let me see if you could try and figure out who would be least fit. And if you looked at the table and said athlete E, you are correct. Now let's reason out why athlete E would be the least fit. His pulse rate before jogging was at 61. Immediately after jogging, it was at 155. And then 5 minutes after jogging, it was at 85. Now, what do you see between the pulse rate before and the pulse rate 5 minutes after? If you said that the pulse rate after the 5 minutes, after stopping from jogging, that is higher, way higher than what it was before jogging, it simply means that athlete E has a long way to go before returning to that normal or resting heart rate he has of 61. So if they have the highest amount or the highest pulse rate after that 5-minute recovery time, it's an indication that that person is the least fit. So it's going to take him a greater period of time to return to 61 that he actually started with. All right. And a way to state this on your exam paper would be that athlete E had the highest pulse rate even after the 5-minute recovery time, and this is a sign that he's the least fit of the group. So let's go, because we're getting there. Suggest 2 factors other than exercise that may have an effect on pulse rate: your age, your emotions, consumption of drugs such as alcohol or coffee, cardiovascular diseases such as hypertension and heart failure can all have an impact or an effect on your pulse rate other than exercise. All right, so any of those two would have given you 2 marks, and that's a 15 marks question, and I know you guys would get all marks there, not true? Next part of the paper, we're at question 3, so we're exactly halfway through the paper, and we have another table. It says table 3 shows some properties of metallic and non-metallic elements A, B, C, and D. Now, table 3, properties of metallic and non-metallic elements, element A, B, C, D. It gives us the electrical conductivity, meaning if it can conduct electricity. A is a conductor, B is a non-conductor, C is a conductor, and D is a semiconductor. The melting point is high for A, and the density is also high. For B, the non-conductor, the melting point is low, and the density is also low. For C, the conductor is high, the melting point is high, the density is high, and for D, the semiconductor, the melting point and the density are also both high. Now the question asks, suggest with a reason one element in table 3 that is a metal. Now, I have as my answers elements A or C. Now, the reason I put A or C is that they can conduct electricity. So if we look, they're both conductors. And also for the fact that they have both high melting and high density readings, right? The reason I didn't put the semiconductor there is obvious. If it's a semiconductor, it simply means that it may not be a metal, because we do have objects which are not metals that can conduct electricity, such as semiconductors. So, but they asked us for a metal, alright? So the metallic choice would have to be A or C, and that would give us 2 marks right there, guys. Now, part 2 to the question asks us to suggest 2 uses of element A and 2 uses of element B other than for making cooking pots. And the reason why they told you specifically in this question other than cooking pot is because we know that is the example that most people would run to, so you have to think outside of the box sometimes. So how could I use A, which we say is a metal, and based on the table, element B is a non-conductor, so we kind of have the idea that it's a non-metal, right? So how do we use an A, metal, and B, a non-metal for uses other than making cooking pots, alright? Now I have for element A, the construction of electrical wires. Not true, that's what we use in our electrical wires. We use metallic wires. 2, we could use them to make jewelry, a lot of rings, a lot of chains. We use metals to wear for jewelry. 3, you could use it to make building material, so steel to build houses, tools such as hammer, the head of the hammer, and the nails for construction. So just think about any way at all you could use metals. And then B, which is a non-conductor, I said it can be used to make food containers, furniture, clothes, or even shoes, because we do not know exactly what the material is or what the element is, but we know it's not a metal. So anything that you could use it to do, then you could state it here. You would not be penalized if you said clothes or shoes, because they're basically saying it could be any type of non-metal. So it could be material, it could be fabric, it could be plastic, it could be rubber, it could be anything apart from a metal. Now, the next part of the question says, explain one advantage of using the following to make cooking pots. So sorry for this part. It says plastic. Plastic is used to make pot handles, right? And pot lids in order to prevent the transfer of heat from the metal pot to the person during cooking, to prevent burns that can cause injury to a person. And we know that's why they put it there. And how is aluminium useful when we use it to make cooking pots? Aluminium is a lightweight metal, and so it makes pots easier to handle, and it conducts heat very quickly, so your food is cooked at a faster rate. So that would be for 4 marks. Now, part C. List 3 factors that can affect the rate of rusting of metal fixtures in houses located near to the sea or industrial plants. So we move on to rusting. Now, these are some of the factors that could affect those metal fixtures, located near the sea. So we have exposure to moisture from the air, because if you're closer to the sea, then the air there is going to be filled with a lot more moisture than inland. 2, salt dissolved in the water, especially if those homes are close to the seaside. We know if you live close to the seaside, they have a lot of splashing from waves. So eventually those particles of water that have dissolved salts in them would be sprayed onto the houses and can also cause rusting. Oxygen exposure. Remember, anywhere you are, you are exposed to oxygen. So you have open air there, so a lot of oxygen is there, which does increase the rate at which rusting occurs, and also warm temperatures. We know that heat is something that can increase or speed up the rate of a reaction. So any one of those, and you get your 3 marks. Now it says for part D, John makes iron burglar bars for the windows in his home. Suggest 2 ways by which he could prevent the bars from rusting. So you saw the first one already. Painting, by using paint to cover the iron bars, and I'm sure you do this at your home. In the Caribbean, we use a lot of grills to grill up our homes, especially in Jamaica, and for the most part, we know that persons always paint their grills because they don't want them to get rusty. So painting, just getting a regular tin of oil paint and painting over those metal bars. 2, galvanizing is another way, where you use molten zinc to cover the iron bars. This isn't really done at person's home, but usually it's plants like businesses that actually make metal objects. They can do galvanizing for you if you request it, or they do sell it to you when you get the product. So the product comes galvanized. 3, adding a layer of oil or grease to the iron bars. This is the cheapest, easiest way, where you can just put some oil over the metal bars. 4, tinning, which is a thin layer of tin is used to coat the iron bars. And then 5, we have electroplating, where a thin layer of a non-conductive metal is used to coat the iron bars. So any one of those, guys, any one of those 2, and you would have gotten your 2 marks. And that's for 15 marks. We're on to question 4, and if you're just joining the paper, if you just clicked on the paper, we're looking at integrated science paper 2 from May-June 2017. Question 4. Many environmentalists are calling on Caribbean countries to be less dependent on fossil fuels as a source of energy and to move towards the use of alternative sources of energy. So it says, define the term fossil fuel and state 2 examples of fossil fuels. And guys, these questions about environmental solutions and environmental problems are always on your paper. So it would always be wise to make sure you study this section of your syllabus. Make sure you study this part. It's an ongoing worldwide problem, so they're always going to ask about it to see students' knowledge, how well you are understanding what's going on around you. So fossil fuels, and name 2 examples. Fossil fuels are made from decomposing plants and animals under intense pressure conditions over long periods of time. These fuels are found in the Earth's crust and contain carbon and hydrogen, which can be burned for energy. And examples of fossil fuels are coal. And I'm not talking about coal that we use in the Caribbean when we're doing like jerk chicken or barbecuing, where you cut down the trees and you burn. No. This type of coal is what they mine for. They dig for this. And it looks like hard black things. They almost look like black rocks. Oil that they drill for and natural gas are examples of fossil fuels. Alright? And that's for 3 marks. Next part of the question, suggest 4 environmental problems that can occur as a result of the use of fossil fuels in the Caribbean. Now, if you're looking at fossil fuels, guys, always think about the fact that for us to use these fuels, we always burn. So let's look at what I have. Fossil fuels, when burnt, produce harmful gases that lead to air pollution, that affect the air quality and can lead to respiratory illnesses. And remember, guys, these fossil fuels are what we use in our cars and what electric companies burn to actually produce electricity. So once you're burning something, gases are going to be produced that will harm the environment. 2, these harmful gases can lead to global warming, which then leads to long-term climate change. 3, oil spills can lead to the death of aquatic animals and plants. 4, fossil fuels when burnt can lead to acid rain formation. 5, fossil fuels produce harmful gases that can lead to photochemical smog. And if you go back to your notes, your textbook, your syllabus, they mention acid rain formation and photochemical smog formation, and both of them come from using fossil fuels. So just take a note of these environmental problems that results from us using fossil fuels within the Caribbean. And that's for 4 marks. B, identify 2 alternative energy sources to fossil fuels other than solar energy that can be used in the Caribbean. And when you see the term alternative energy sources, they're just asking you for renewable sources of energy sources that we can get from our natural environment that would not harm us, or they can be replenished. And in this question, they basically suggest to you that they do not want you to say solar energy. So what can we use instead? In the Caribbean, we can use wind energy. For those of us who live in Jamaica and other Caribbean countries, we have wind turbines. So looking at the wind turbines should give you an idea that, hey, we use this as an alternative source for electricity or energy. 2, hydroelectricity. This would be where you use running water from waterfalls to turn turbines or to spin turbines to produce electricity. And we also have geothermal energy. Geothermal energy would work for Caribbean countries that have volcanoes which are active. So those would be 3 alternative sources, even though they ask for 2, because that is what we do here. We give you more than you ask for just to make sure you remember something when you're going to do your paper. This part of the question, discuss 2 advantages and 1 disadvantage of using solar energy to satisfy the national energy needs of a country. And my advantages are: 1, solar energy is derived from the sunshine, which is available in the Caribbean because of its tropical climate. Solar energy is readily available, which is one of the advantages, as well as the fact that it is infinite. We cannot really turn off the sun, so it is ever-present source. So that's an advantage. 2, solar energy is free. There is not a cost for the actual energy source. This would reduce the cost of energy as countries would not need to purchase any resources. And if you know, Caribbean countries are not considered first world countries, so we always have to purchase, unlike Trinidad and Tobago, those of you down there who have your own oil. But for other countries that do not have access to fossil fuels, we need to purchase. So if you have the sun that no country owns, then all countries who have sunshine can access that without paying a cent. 3, solar energy does not produce any harmful substances, therefore it does not contribute to pollution. So that's another advantage, guys, and it's called clean energy. So those are the advantages of using solar energy. So let's look at the disadvantages, and some persons would want to say, then what would be a disadvantage? The disadvantage would be that energy production is reliable on weather conditions. So the disadvantages are: 1, energy production is reliable on weather conditions. Therefore, if there is a period of cloudy or stormy weather, then less energy will be produced. So that's a drawback. And 2, countries would need to invest in storage of solar energy, which could be costly for the country to build or source like a storage or a power bank to store this energy, because once you have solar energy being produced or harvested through solar panels, you need to secure it or store it. Let's move on to the next question. Section B. So we're at question 5. We're almost finished. In the space below, it says draw a circuit to test if a material is a conductor. The circuit should consist of a switch, bulb, cell, and connecting wires. Use circuit symbols in your drawing. Now, I couldn't draw using the pen in the PDF, so this is what your diagram should look like if you're planning, or if you get one of these diagrams to draw in your exam. So the question asks us to make sure that we see the cell, the bulb, the connecting wires, and the switch. So I have all of these labeled here. And also this is where we would put the material that we want to test, if it's a conductor or not. So this is the symbol for the cell. Remember that, guys. This would be your switch. These long lines would be your connecting wires, connecting your cell to your switch to your material here, your bulb. All of those lines around are connecting wires for the circuit. And then this structure would be your bulb, the circle with the X right across it. So make sure you know your symbols when you're drawing circuits. Have a good look at this. And let's get back to the paper, and that question would be worth 3 marks. Now it says give one example of a good conductor of electricity and one example of a good insulator of electricity. Now if it's not conducting electricity, then it is considered an insulator. So just think about other materials which do not conduct electricity, and you will figure out what an insulator is if you're not familiar. Not everybody studies all parts of the syllabus, so that's for those who don't know. So good conductors would be metal. You could have iron, steel, aluminium, any metal you know. And then a good insulator would be rubber, wood, plastic, or even cloth. And any one for each would give you your 2 marks. Moving on, it says name one safety device used in circuits to prevent overloading and state how this device works. Now you already see the answer. The device is called a fuse. And how does a fuse work? A fuse is a piece of metal wire found in the circuits of appliances that melts if too much electricity is passed through the circuit. The fuse will melt, thus breaking the circuit, so that the appliance does not get damaged by the large load of current. So this would be for 2 marks, and we're moving on quickly. Part B of the question I may have a little image here. It says Jenna's kitchen is flooded with broken water line and her blender's electrical cord is frayed or exposed as shown in the figure. And we see the exposed electric cord right there. And the diagram showing the blender with the frayed electric cord. Now it says, suggest 2 hazards that may occur if Jenna attempts to connect the blender to the electrical outlet. Now guys, what do you think is going to happen? Obviously, a hazard would be a shock hazard. She could be electrocuted if her hands touch the frayed wire while she's plugging it into the socket. 2, there could be a fire hazard. A fire could occur due to the damaged appliance coming in contact with the electricity. So any two would give you 2 marks. The next part of the question is continuing from Jenna and her broken blender. It says figure 2 shows the frayed electrical cord of the blender plugged into the electrical outlet. Suggest 3 pieces of protective gear or wear which Jenna should use before attempting to remove the frayed cord. Now, gear 1, rubber or insulated gloves, because if she's going to touch that, she does not want her hand coming in contact with electricity. 2, she could have on a rubber apron or shoes. And 3, she could use a face shield in case there are any flying sparks. She doesn't want anything to get in her eyes, and she wants to make sure she has clear vision of what's going on. She doesn't want, when sparks begin to fly, that she has to be closing her eyes and then she doesn't see what she is doing. So those 3 would have given her or given you your 3 marks. Now, the next part of the question says, Jenna notices that 3 wires in the cord are blue, brown, and green. And if you do electrical along with integrated science, this is easy for you. And it's asking to just choose the wire and which part of the circuit that color will represent. So the blue wire would be your neutral, brown would be your live, and green your earth. Now, these are the colors in the integrated science syllabus that I am used to seeing, but I've also seen some where we have black and red as some of the colors for the wires. Just make sure you have a good sense of knowledge if you see a question like this of which colors represent what part of the circuit, and that would be for 3 marks. And we're at question 6, the final question of this paper. It says, state 3 differences between the nervous system and the endocrine system. And here we have 3. Now, for the nervous system, it uses electrical impulses to carry messages to different organs in the body, but the endocrine system uses hormones. 2, the nervous system uses electrical impulses through neurons, but the endocrine system uses hormones. And 3, transmission of impulses in the nervous system is fast, but transmission of hormones in the endocrine system is slow. So those are the 3 differences. Go through your textbook, go back through the syllabus, make sure you can compare these 2 systems in the body, see what they have in common, see what they do not have in common, so you have a good idea of how you would answer this question, because I've seen this question not only on integrated science papers but also on human and social biology papers. So if you know persons doing HNS, sometimes it's good to even look at other subject papers when you're studying or preparing for your exams. Now, part B of this question states that Sita is cooking while she's talking on the phone. She accidentally picks up a hot pot and without thinking immediately drops it. Outline the activities occurring in the nervous system which causes Sita to drop this hot pot. Now, the first thing that happens is that receptors in the skin receive the stimulus from the hot pot. 2, a sensory neuron then conducts the impulses from the receptors to the central nervous system, or the CNS, in the spinal cord. 3rd, the impulses are transferred from the sensory neuron, which is in the CNS, to the motor neuron. And then the motor neuron transfers the response impulse to the effector muscle in the arm to pull away from the hot object and let the pot draw. So this is what we call the reflex arc, and if you are not familiar, please go back to your syllabus, your textbook. Cannot stress it enough, and revise this part of the syllabus to make sure you have a better understanding, and always try to break down steps into smaller pieces so it's easier to understand for you. And if you answered it like that, you would get 4 marks. And I think this is the final question. It says Lee has difficulty seeing the board when he sits at the back of the class. The doctor tells him that he is short-sighted and requires glasses or spectacles. With the aid of diagrams, explain what is meant by short-sightedness and how spectacles are used to correct this problem. Now, short-sightedness is also called myopia. So if you don't see that word short-sightedness, and you see myopia, they're talking about the same thing. Short-sightedness, what we call nearsightedness, myopia, they're all the same thing. And it is a very common eye condition where you cannot see objects far away clearly. In people with short-sightedness, the cornea curves too steeply, or we say the eyeball is too long. And it's usually corrected with concave lens in glasses or even contact lenses. And they ask us down here for diagrams, a space for diagram showing short-sightedness, how it looks, and a space for diagram showing correction of short-sightedness. Now, if you're not a drawer, you have to at least learn how to sketch these diagrams from memory, or else you'll be missing out on 8 marks, and you cannot afford that, guys. So do not give the excuse that you cannot draw, but always try and even do a little sketch, because your grade depends on it. So let's look at the diagrams I have. So we're going to look at the diagram for short-sightedness and for the correction of short-sightedness. Now on the screen, let me zoom this a little bit for you. This diagram you see here is showing you short-sightedness. So you have the light ray from the far object coming into the eye right here, passing through. But remember, for us to see an image, the focus must be placed on the retina. But if you realize, the focus is in front of the retina, and that is why we say the person with short-sightedness or myopia, they have a long eyeball. So their the ball is too long. So by the time the light rays from the object are supposed to be placed on the retina, it is formed in front of the retina just because the eyeball is too long. So it's way too big for the image to form on the retina. So that's what a myopic eye or short-sighted eye looks like. That's how the image is formed. And you have the focus here in front of the retina. So let's look at how you would fix it. So this would be your diagram for the first one. And then this one would be the second diagram when it is actually corrected. So the light ray from the object, and then they would place a concave lens in the glasses or in the contact lens that you would wear to correct this eye problem. And then you would see that the concave lens bends the light rays coming from the object so that the focus of the image is now placed exactly on the retina. So this is how it is corrected, because when you see, the image must be placed on your retina for you to actually see. So this is the corrected, and this is it before correction. So you can view both of them side by side to get that feel. Alright, so this is the end of the integrated science paper 2, May-June 2017. Guys, study. This has been Past Papers 101 with Miss Edwards. Remember, guys, with God, all results can be distinctions.